Welcome to the Dairy News and Views podcast, a production of the Iowa State University Extension and Outreach Dairy Team. Our podcast covers current educational, research, and industry tools available for your operation to manage healthy cows and calves while producing the highest quality dairy products.
Just to start out, what is composting? Basically, we're just talking about, the biological decomposition of organic matter, organic material under controlled conditions. And that's the key distinction here. So just taking some bedded pack and piling it behind the barn and letting it sit for a few months. Some people kind of consider that to be composting. That's not really composting. That's not a controlled process where you're hitting certain temperatures and times and things like that. So we'll go through what actually makes it composting and how to do it successfully. So the key here, composting is a biological process. So it's the organisms, those, microbes and fungi and everything else that are in that compost pile that are doing that breakdown of that manure or carcass or whatever it is you're trying to compost. And then you're going to end up with a stable end product when you're done. There's a couple different temperature ranges that we'll typically see in composting. So I'm talking about aerobic composting here, where we're going to have oxygen in that pile. So in the 50 to 110 degree temperature range, that's mesophilic composting, mesophilic organisms that get that process started, and then they'll take over again during the end of the process when it's cooling back down. But when the real work happens is in the thermophilic phase. So that's 110 to 160 degrees. And that's where most of that active composting is going to take place. So we want this to be an aerobic process. There's an exception to that I'll get to in the next screen. But generally, if it's aerobic, you're getting lots of oxygen into that compost pile. It's going to be an efficient process. You're going to minimal odors. Everything's going to work well. If you're trying to do it aerobically and it turns anaerobic, it becomes starved for oxygen. That's not good. That's when you start having odor problems. You start seeing leachate coming out of the pile and all kinds of issues that we don't want to see during composting. So I mentioned we want this to be aerobic, and I just have one slide on this, but I wanted to mention it because there's probably some confusion if you do some searching online about composting. You might come across these methods. There are actually anaerobic composting methods, but there's two key distinctions here. One, this is an intentional process. You're intentionally doing this anaerobically. So you're going to cover that pile. You can do this in silage bags. There's other ways to do this. You may have heard of the SPICE method, static pile inoculated compost extension, or bokashi composting. If you search online, you can find these little kitchen top bokashi composters for your table scraps. You can scale that up and compost just about anything with it. But the key here to making this work is you have to inoculate that compost with the proper bacteria that allow that fermentation process. It's actually a fermentation process. So think silage here. This is just like making silage. It's going to ferment, and you have to have the proper bacteria. For that to happen, you have to inoculate it. So generally going to be lactobacillus species, or what people call EM, or effective microorganisms, if you're searching for that. So I wanted to mention that. That's not what I'm going to cover today, but there are anaerobic composting methods. So as far as the aerobic composting, there are different phases. And how long this is going to take really depends on, if we get into mortality composting, it's going to depend on the size of the animal. It's going to depend on the weather conditions, what time of year you start this. But generally, it's going to go through an initial mesophilic phase. You're going to hit that thermophilic range for a number of weeks, and then it's going to start to cool off again. The key to making all of this work are these 5 parameters that go into successful composting. I'm going to go through each one of these. So moisture content, your carbon to nitrogen ratio, the oxygen content, temperature, and particle size. If you can manage those 5 things, you can successfully compost. So starting out with moisture, in the 50 to 60% moisture range, that's kind of the ideal range where you want to be. You can be a little bit outside that, and it's fine. Again, this is a range, but if you get below 40, you're getting in that area where it's going to be too dry, and you're not going to have enough moisture for those microbes to be able to do their job. On the other end, if you get over 65, that's generally going to be too wet. A lot of your pore space starts to fill up with water, and you have a hard time getting enough oxygen into that compost pile for good composting. Carbon to nitrogen ratio, Again, there's ranges here. Generally, you want to be in that 20-to-1 to 30-to-1 range for successful composting. If you have too much carbon, not enough nitrogen, that's going to slow down your decomposition process. The microbes aren't going to have enough nitrogen to do their job. On the flip side, if you have too much nitrogen, that's where you tend to see odor problems. You start getting ammonia volatilization off the compost pile, and we don't want to see that either. So you want to try to hit that 20 to 30-to-1 range on the carbon to nitrogen ratio. And the way you do that is by matching up the seed in ratio of your feedstock, whatever you're going to blend your manure or your carcass with, to the material you're trying to compost. So, for example, if you've got some manure that's 20-to-1, that's a little bit on the lower end, you're going to want to mix in something, some corn stover or something like that that's got a higher carbon to nitrogen ratio to bring that total ratio up a little bit. And so this takes a little bit of art, a little bit of science, some trial and error to get that carbon to nitrogen ratio where you want it. Oxygen, incredibly important for this process. That being said, there's really no practical way to measure the oxygen content on the farm. There are tools to do that with. It's not really feasible or practical to do it. The way you manage oxygen is by having the right particle size and building your compost windrow correctly so that you get enough oxygen coming into that pile. Temperature is very critical. Again, if we don't hit that temperature range, thermophilic bacteria like that 110 to 150 range, you're not going to have good composting happening. If you're wanting to kill pathogens and you're wanting to deactivate weed seeds, you really need to get that temperature up. So 135 for pathogens, 145 for weed seeds, but we don't want to be too high or too low. Again, there's kind of a Goldilocks range there. If you get over 160, your microbes actually start to die off. That's too hot. They can't survive in that. Whereas below 110, it's really not composting, or it's composting very slowly. You're going to have very slow decomposition. So getting it super hot isn't necessarily a good thing. And there's ways to deal with that. If it gets too hot, you're probably going to have to turn that compost pile or the windrow. Particle size, this is how you basically manage the amount of oxygen you get into the compost pile. So how fast it's going to break down, it depends on the particle size. So your small particles, they're going to degrade faster. Your larger particles are going to break down slower. So for composting, generally in that 1/8 to 2-inch diameter range is, a nice blend. You don't want everything to be one size. You want to have a blend of different particle sizes somewhere in that range to get good, oxygen transport through that windrow. If you have too many fine particles, it's going to be too dense. And you're going to have a hard time getting enough oxygen in for good composting. So that's kind of the basics behind all composting methods, those 5 key parameters to make composting work. And so now I'm going to switch gears a little bit and go into the planning phase. Say you want to do this. What do you need to think about for composting projects? If you're going to do this on farm, you got to think about traffic, space requirements, where you're going to put these compost windrows, and then keep in mind, if you're doing more than one windrow, you need room to get in there and turn those windrows. So you've got to have enough area in between them for whatever equipment you're using, whether that's a skid steer or just a tractor with a front end loader or a payloader, or if you have an actual compost turner, you have to have room to get down between those windrows to turn them and to manage them. You need, space for your finished compost. If you're going to move that to a different area, you have to think about labor. It does take time to do this. You have to build those piles. If you're going to try to make a high quality product, especially if it's something, maybe you've got more manure than you need and you're going to want to sell that product off farm, you're going to have an accessible area for that where people can come and pick it up. It takes labor, it takes management. You're going to be turning those piles fairly regularly. Drainage is another thing that you really need to pay attention to. So you want to do this properly so you're not causing a water quality concern and having issues, with the DNR. So you want a relatively dry, relatively level area with good drainage so you don't have any surface runoff coming into where your windrows are. Maintaining the pads, keeping your weeds down around the site, things like that. So this takes planning, it takes time to do this successfully, but it can be done. Site selection, very important. You need a relatively impermeable base that you can access year round. Ideally, you can do concrete, you don't have to. You can just do a packed soil or a gravel base. Slope is actually a good thing if you have a little bit of slope and you can run your windrows up and down the hill. That allows runoff water to run down between the windrows instead of getting trapped behind them, which would happen if you run them across the slope. But you don't want it to be too steep, because you get over 6% or so, you're going to start having runoff issues, possible erosion of your pad. So 2 to 4% is actually pretty good. If it's completely flat, sometimes you can have issues with keeping that water away from your windrows. So consider the location, think about where your neighbors are. If you're going to have a larger facility in particular, it's better to keep that back away from the road. Screen from public view is probably better. But if you do this properly, you really shouldn't have that much in the way of odors or fly problems or things like that. So how do you find a good location? Well, Iowa DNR has an animal feeding operations siting atlas. It's a handy tool for this sort of thing. It's got a little measuring tool in there, and so you can go in and just find your location. It's got some drop downs here on the left side where you can turn on the different layers. It shows you where all the surface water is. It shows you where sinkholes are, and you can use this little measuring tool in there to, create measurements. The other thing you can do is if you click on any one of these, every one of these little pink dots is an active facility. If you just click on that, if you're on that map, it'll pop up a sidebar on the right there, and it'll tell you how far you are away from water sources and sinkholes and things like that. So handy little tool to use if you're thinking about siting, and you can use this for buildings or anything. So managing leachate and runoff, again, very important. You want to divert that clean water away from the site, get it to infiltrate somewhere before it ends up in the surface water. You don't want any, contaminated or dirty water or leachate coming out of that pile and ending up in a surface water, because that's where you're going to have water quality problems. So some sort of a treatment area is good, vegetative treatment area or berms to treat that before it gets to a waterway. Think about, seasonality. There's certain times of year, wintertime, you're going to have snow piles to deal with, or maybe you just don't compost in the winter. You have to think about what you're going to do in wetter periods and when you have a lot of snow to deal with. So that's a little bit on planning compost facilities and just thinking about the logistics of making it work on your farm. Now I'm going to get into the actual process and the differences between composting manure versus mortalities. And so if we're thinking about manure composting, you have to think about what can you actually compost. So basically it needs to be stackable. It needs to be something you can handle as a solid. If you can do that, you can probably compost it. So think bedded pack manure, poultry litters, poultry manure, things like that can be handled dry. You can compost it. You're not going to take liquid swine manure or liquid dairy manure out of a pit and compost it. There's just way too much water. It's going to take way too much carbon to soak up all of that material. That being said, there are technologies out there to separate manure. Lots of dairies have solid separators, probably reusing that on site, but maybe you have a situation where you have more manure than you need and you want to sell that. You could take that separated manure and compost that material. That is doable. Having said that, you have to be careful about sand. So if you're using sand, you don't want that in your compost pile. So you want the compost to be organic materials, anything that can break down and turn into organic matter. You don't want any sand or any dirt in your windrow, or you're going to have problems trying to get it to compost. So keep that in mind. If you are separating manure and you're using sand, you need to get that sand out first, and then you could potentially compost those manure solids. So why would you want to do this? A big one is volume reduction. So you're just going to have less material to haul out. 50 to 70% less by the time that composting process is finished. If you're doing it properly, it can reduce odor problems, it can reduce fly problems. And again, it needs to be aerobic, and I'll get into some things you can do to help manage that specifically for mortality composting. Generally, most farms are going to have the equipment that they need already to do this. So, you can buy a compost turner, but you may be able to get by without one. Unless you're doing a whole bunch and you want it to be fast, you don't necessarily need one. You can just use whatever loader equipment you have. And then there are situations if you're wanting to move manure across state lines, if you can compost it, that can get you around some of those regulations for that. Other reasons I mentioned earlier, you can kill pathogens, you can deactivate weed seeds. That's a big benefit of doing this. again, you got to hit the proper temperature in order to make that happen. More uniform applications, another one. So think bedded pack manure. It tends to be really clumpy and not very consistent. So if you can compost that, you're going to have a much more consistent, more homogeneous end product. It's going to be easier to get that evenly applied on the field. And if you can make good quality compost, and again, quality is the key word there. If it's turning anaerobic on you and getting stinky and you got leachate, that's not going to be a good quality compost. It's not going to be as beneficial as a soil amendment. But if you can make good compost, it's an excellent soil amendment, very biologically friendly to your soil, can help increase your organic matter levels, your water holding capacity of your soil, help reduce bulk density, all the soil health stuff that we talk about. Compost is excellent for all of that if it's a good quality product. So getting into the specifics of composting manure. So if you're going to most likely going to do this in a windrow configuration, and the size of that windrow is really going to depend on your equipment. So there's no hard and fast rules here. Generally, your width is going to be somewhere in the 8 to 16 foot wide range. Again, whatever you can handle with your equipment and get it turned. If you go much beyond 16 feet, it gets really hard to get oxygen into the center of that windrow. So that's kind of the upper limit. And then the height is basically going to be roughly half your width. So say you make a 12-foot wide windrow, for example, it's going to be somewhere around 6 feet tall. And then you're either going to blend all that material ahead of time, put it in your windrow, or you can use a layering method. You lay down some carbon, you put some manure on, lay down some more carbon, and do kind of a stacked layer type design. And then after a week or two, you can turn that and get it blended in. Again, make sure you got enough room to get in there and turn it. And if you're a little concerned about maybe not having enough porosity, getting that pile to heat up for you, it can be helpful to start with a base layer of more porous corn stover, straw, maybe some wood shavings if you haven't access to those, something like that, to help get oxygen in that pile and get it started. Operation and maintenance. So once you've got it built, it should hit temperature within 5 to 10 days. You should be up over 100, 110 degrees. But again, that 130 to 150 range, that's really that's the sweet spot that you're trying to hit. And again, if it gets over 160, you're probably going to have to go in and turn it. If it's below 100 and it's not warming up, you've got some issues there. I'll talk a little bit about troubleshooting piles towards the end, but possibly too dry, or you don't have enough nitrogen, or there's something going on there that it's not heating up. Basically, once it's built, you just monitor your temperatures and you turn that pile as needed to aerate it. So that's animal manures. Now I'm going to shift gears and talk about animal mortalities. Again, the biological process is the same, but there's a different process to go about building this windrow if it's specific to mortalities and not manure. And I'll get into how you do that because it's very important. So composting mortalities, why do you want to do this? Well, it's relatively inexpensive. It's quite easy to do. You get away from any biosecurity issues and rendering truck fees, having them come on and pick up animals. That's getting harder and harder to even find rendering services. Burial can be an option in some locations, but it's also not an option in a lot of locations. And you do need to be aware if you're going to compost mortalities, there are DNR regulations around that. I'm going to go through some of those. They'll sound kind of scary. It's not that bad. If you build the pile properly and you do it in a good location, you'll be fine. And it can make a good quality, high carbon end product, but you do have to keep in mind now that we're talking about mortalities, it's probably going to have some bones in it, especially for larger animals. So it may not be suitable for a product you're going to sell, or you're going to have to screen those bones out before you sell that product. So I mentioned burial. It's an potential alternative to composting, but there's a lot of challenges with deep burial. So this is the Iowa DNR actually has a map for Iowa. You can find this, a burial map. If you go in there and you look at the map of the whole state, you see a lot of red there in eastern Iowa. That's a high risk area. You're shallow to bedrock. It's steep. There's a lot of runoff. And then anything that's grayed out burial is prohibited. So basically you're too close to a water source, or your water table is not deep enough to be able to do deep burial. There's a good portion of the state of Iowa where you just can't do deep burial. So it's not even an option. There is a variation on that. I'm just going to briefly mention this. As far as I know, this has not been approved yet in Iowa. So if you're in another state check with your DNR and see if they allow this. It's a relatively new method, still being researched, but it's called shallow burial. It's kind of a halfway in between composting and deep burial. So the way this happens is you dig a 2-foot deep trench and you put about a foot of carbon material in the bottom. So wood chips, corn stover, straw, something like that. So it's similar to composting in that manner. But then you're going to take that soil that you excavated and just put it back over the top of the carcasses and then plant vegetation, grass, something on top of that, and just let it sit. The thinking here is after a year or so, you could return that to productive use. So if you did this out in the field, you let it sit for a year, and then the next year you could go back to farming it. So again, potentially a good way to deal with mortalities. Make sure you check with your state regulatory agencies to see if they allow you to do this. So back to mortality composting, there's different ways to go about it. Probably seen a lot of these bin composters, very common on swine facilities. The big advantage of doing those is dealing with the runoff. So if you've got a roof over it, your compost pile isn't getting saturated from excess rainfall. You're diverting any of that clean water away from the site. So huge advantage there, but they are very expensive. And there's concrete divider walls between those different bays, and that basically cuts off your oxygen flow. So it can be difficult to actually make decent quality compost in these bin systems. Whereas your static pile or windrow method, extremely cheap, very easy to do, but you have to build it properly and do it in the right location to minimize that potential for runoffs. If you don't manage it properly, you're going to have a mess. You're going to potentially be causing water quality problems. So how do you do this? So absolute key for mortality composting is that base layer. So 18 to 24 inches of carbon material. So again, wood chips, corn stover, might be able to use straw, something with decent porosity, and then you lay the carcass on top of that. And there's several reasons why you need that base layer. One is if you think about, let's say we're going to compost a 1,400 pound Holstein cow. Those carcasses are about 80% water, 80% moisture. So as that process starts and that carcass ruptures, a lot of that moisture is going to be released, and you have to have something to soak up all of that liquid. That's the first reason that base layer is absolutely critical. And the second reason is it allows oxygen into the pile. So if you think about this versus composting manure, with manure, if you need more oxygen, you can just go in and turn the windrow. If you've got a 1,400 pound carcass in that windrow, it's going to be probably months before you're going to be to the point where you can turn it. So once you build it, you're kind of stuck with it. So you have to build it properly. You need that base layer under there so it can bring oxygen into the pile. So the way these windrows work is composting process. Those organisms create a lot of heat, and it creates a chimney effect. So that heat rises, it's going to go up and out the top of the pile, and that basically draws in your fresh air from the sides. So you need that process of fresh air coming in from the sides and under and then up through the center of the pile to have good composting for carcasses. So you lay down your carcass, and then this is a great place if you've got some bedded pack manure or spoiled silage or feed bunk refusals. Go ahead and put that kind of thing on top of that carcass. That can really help with the composting process. And then you're going to cap it. So this is another thing that makes it different from composting manure. So you need that cap for a couple of reasons. One, it helps kind of insulate it and keep that heat in. Because again, this is going to be a longer process. You're not going to be able to turn that pile right away. The other thing it does is it helps a lot with preventing odors and preventing scavengers. So if you just put the carcass on and dump some silage on it and you don't have it thick enough, you're going to have lots of odor. You're going to have skunks and possums and raccoons and dogs and everything else coming and digging into that compost pile and potentially pulling out parts, and we don't want that happening. So you need that nice thick cap on there to keep those odors to a minimum and keep your fly problems and your scavenger problems to a minimum. Again, you want a minimum of 18, preferably 24 inches of material all the way around that carcass. So again, you lay down your carbon base layer, you put the carcasses on top of that, and then you cover them and you cap it. So it's a relatively simple process. Once you build it, you're not really monitoring temperatures here like you do with, a regular compost windrow. You're pretty much going to build it and you're going to leave it sit. And then at some point, you'll probably go in and turn it. But there are, regulations around where you can do this. So just keep that in mind. There are separation distances, 500 feet from residences. If it's your own house, it's not a problem. Separation distances there for wells and streams and property lines that you have to keep in mind. So that's where that map where you can measure out distances can be handy to make sure that you're far enough away from these different things. Big one though is just making sure you don't have any leachate coming out of that compost pile. It's really what the DNR is after. They're just trying to protect water quality. That's the goal at the end of the day. So if you build that pile properly, you have that nice thick base underneath it to soak up that leachate, you shouldn't have issues there. Make sure you're doing this again on a relatively all-weather relatively impermeable base. Doesn't have to be completely impermeable, but they do want it to be something that you can access year round. If you're going to be using this for mortality composting year round, you need to be able to get to it. Again, no runoff into or out of the pile. Do what you got to do to make sure you're not contaminating a surface water source. And the beauty of windrows, if you think about sizing, if you're going to build a facility, with the different bays in it, it can be a little tricky to figure out how big does it need to be, how many bays you need, how do you size it. With an outside windrow, you just make it as long as you need to make it. If you get to the end of your pad, you move over, start a second windrow, and just let the first one sit there and cure. By the time you have your second one built, or third or fourth, however many you need, then you can go back to the first one. That's ready to go. You can haul it out and you can start over. So essentially, as long as you've got a relatively big area to do this, you're never going to run out of room. They do want that process to start within 24 hours. So, don't leave those carcasses laying around for several days and then put them in, get them covered up right away. It should stay in that compost pile until all of your soft tissue is fully decomposed. Again, with bigger animals, you will have bones. You're going to have skulls. You're going to have hip bones. So one way to deal with that, if you can sort those out, you probably don't want to haul those bigger bones out to the field. Put them back in the compost pile and go through that process a second time. By the time they've gone through that, they're going to be pretty soft and they're going to break up pretty easily. They do want it to be applied, within 18 months after it's finished curing. And there's a few other miscellaneous rules. Again, it seems like a daunting list. It's really not that bad. If you build it properly, get the base under it, get it in a good location where you're not going to have water running through it, you're going to be in good shape. So that's basically the nuts and bolts of mortality composting and how it differs from, regular composting manure or other materials. I did want to briefly talk about emergency mortality composting because this is a little bit different yet from regular mortality composting. Why would you want to do this, or when would you do this? So here we're basically talking about situations where there's maybe a foreign animal disease outbreak. Foot and mouth disease could be one example. I'm sure you've probably heard about the avian influenza, high path influenza outbreaks that happened last year and are still ongoing around the country. And so a large number of turkeys and chickens were composted under this set of rules. Other things, natural disasters, tornadoes, floods, hurricanes. Luckily, we don't have to deal with the hurricanes here in the Midwest, but there have been a number of instances where they've had a large number of mortalities and they had to go in there and basically compost them under kind of emergency situation. Barn fires is another one. You hate to see that, but it does happen. You might be faced with a whole bunch of carcasses that you need to be able to deal with at once. So what are your different options in a mass mortality event? Composting tends to float to the top because you can almost always make it work. If you can find enough carbon to do it and a spot to do it, you can compost. Other options, you may be able to landfill, but that, especially in a disease outbreak, that's going to be very limited. A lot of landfills just won't take carcasses. Rendering may or may not be an option for the same reason. There's biosecurity concerns there. Incineration, this is okay on a routine basis for smaller carcasses, but it's really not going to be an option in a large mortality event. And if you remember the foot and mouth outbreak, back in the early 2000s and in Great Britain, you saw a lot of open burning. Well, that's not allowed here in Iowa. So unless that rule changes under some sort of an emergency order, open burning is not going to be allowed. I already talked about the challenges with deep burial. There's a lot of places you can't do that. Shallow burial, not approved yet. It may be, but so if you go back to your options here, composting is really the one that comes to the top that we can generally make it work in almost every situation. If it's a foreign animal disease, That's a little bit different situation. So if that happens, it's a foreign disease, USDA steps in and they take over. They oversee that effort and that composting. If that's decided that that's how it's going to be handled, that has to be overseen by a certified subject matter expert or SME in composting. So USDA has people that are able to do this. We are actively training new SMEs here in Iowa. We're gearing up for potential issues with in the swine industry with diseases, had ongoing problems different years with avian influenza outbreaks. So there are a need for SMEs to do this, but basically they're going to come in, they're going to oversee that process, make sure that windrow gets built properly, because there's certain targets that are required to hit for disease inactivation. And you're generally not just dealing with the carcasses here. It's going to be everything on that farm that's organic in nature, that's potentially been contaminated. So the feed has to go in, any litter, bedding, anything like that, any manure piles that are nearby, they're all going to have to get composted. So it takes a lot of carbon to do this. That's the big drawback of the composting option. You got to have a lot of wood chips, a lot of corn stalks, a lot of straw, old hay, things like that to make this work. But in that situation, it's going to differ depending on the species. For example, with turkeys and chickens, what they are requiring is a 2-week period. So within that initial 2 weeks after you build a windrow, it has to hit 131 degrees for 3 consecutive days. Then after that 2-week period, you turn it, go through a second phase. You have to hit 131 again for another 3 consecutive days. So these temperatures are monitored daily. This is overseen by the SME. And then if you hit your targets, after that 28-day period, they'll release those windrows and they can be moved or land applied. Again, if it's pigs or cows, that window is going to stretch out. It takes longer to get those carcasses to break down. But in a foreign animal disease situation, that's a different scenario. USDA is going to oversee that effort, and they're going to determine how all that happens. There is a variation on that we're doing a little bit of research and trial and error on, and that's grinding. And that might seem crazy, but we've done a couple of demos down at one of the research farms near Ames with this. And the reason you want to do this is it greatly speeds up that process. So if you take a 500-pound pig, for example, and you're just going to put that whole carcass in and compost it, you're looking at several weeks, maybe 2, 3, 4 months to get that carcass broke down and get to the point where you're going to want to turn that depending on, the conditions. Whereas if you grind that carcass and you blend it in with the carbon source, it's maybe hard to see, but that thermometer there, that was taken the next day and it was already up to 160 degrees. So it's a very fast process. You eliminate those issues with the larger carcasses, having to wait for those to break down. And these grinders, it's surprising what they can handle. They're made for forestry waste. That one in the picture there, that's 1,000 horsepower grinder. So it'll grind just about anything. So how long is this going to take? Really depends on the size of the carcass, temperature, how well that pile's managed. Generally, it's going to go through 2 phases. You're going to have a primary stage, the first heat cycle. That's when your soft tissue is breaking down. And then at that point, you're going to want to come in and turn it. Goes through another heat cycle, finishes that breakdown process. And then there's kind of a curing phase at the end where it's basically coming back to equilibrium temperature with the environment slowly cooling off and, finishing that maturation process that compost goes through. Again, really depends on carcass size. So if you're looking at a full-size Holstein cow here, primary stage anywhere from 3 to 6 months to get that carcass broke down. Total time somewhere in the 6 to 9 month range. Again, it's going to depend. If you start this in January, it's probably going to take quite a while before that pile actually heats up. So it's going to take a little bit longer. Whereas your smaller carcasses, you can do those in a matter of weeks. So troubleshooting, what do you do? How do you tell if you've got a problem or if it's composting properly? There's basically 3 things or 3 tools. You can say one is your nose. So sniff test. If you can smell odors, you can smell ammonia coming off that pile, something's wrong. If it's a lot, a little bit of ammonia can be normal, but if it's, a very strong smell, there's something going wrong. Either you got too much nitrogen, you're not getting enough air into the pile, it's potentially too wet or too dry, or there's something going wrong there that you're going to have to address. The other one for checking moisture is just a simple squeeze test. So you take some of that material, take a handful of it, squeeze it. When you let go, if it fluffs back up and pops back open, it's probably too dry. If it clumps together in a ball and your hand is wet after you squeeze it, you got juice dripping out, it's too wet. So you want kind of that nice middle ground. It should ball up, but you shouldn't have a lot of moisture or juice running out. Your hand shouldn't be excessively wet. So ways to correct that, if it's too dry, that's fairly easy. You can just add some water to the pile. The other thing you can do is shape the pile. So if it's getting too wet on you, if you can peak it a little bit more, that'll help shed some of the rainwater. Whereas if you want some moisture, you can actually, make a little divot in the top of the windrow and get it to actually catch some of that water and get it into the pile. So you can play around with that as needed. This is one of the big challenges with outdoor windrows is dealing with moisture. Sometimes you just get too much rain. And then the other big one's temperature. You just need to buy a composting thermometer with probably a 3-foot long stem on it and just monitor your temperatures. If it gets too hot, you're going to need to turn it, aerate it. If it's not warming up, maybe it just hasn't had enough time yet. You need to wait a little longer, or, you might be too dry. You might have to add some nitrogen. You have to do a little troubleshooting to determine what's wrong and then correct that situation. Other, potential issues here. So this is just an example where there was a mass mortality event. They didn't have enough carbon, so they built the windrow, didn't have any base material, and you can see the result. On the left side there's leachate coming out of that pile. Luckily, this is far enough away from a water source. There was plenty of crop ground in between, so it wasn't really an issue. But from a DNR perspective, they don't want to see this. This is not a good situation. There was no cap either, so there was animal scavenging happening. There was lots of odors. It was one of those things that happened. They dealt with it quickly, but they didn't have enough carbon to really do it properly. So these are the kind of things you want to avoid. So just kind of wrapping things up here, general summary, there's 5 key parameters for making composting work successfully: moisture, porosity, oxygen, carbon to nitrogen ratio, and temperature. So those are the things you're going to keep an eye on. Carbon to nitrogen ratio, basically you just try to get that right from the get-go, and then ideally you don't mess with it. Temperature, you just need to monitor. Oxygen, you manage that by just having the proper porosity. And then moisture is the one thing that you might, if it gets too dry, you might want to add a little. Honestly, if you're composting routine mortalities, most people are just going to build it and they're going to walk away, and that's fine. It'll compost. If you got a larger windrow mass mortality event, you probably want to do a little more active management. And if you're trying to make a high quality compost out of manure to use on your fields or to sell it, then you're going to do much more active management of that windrow. Make sure you're turning it when you need to, keeping that moisture range where you want it. So there are relatively wide ranges, relatively easy to achieve. Moisture is probably the biggest challenge, particularly here in Iowa and the Midwest. Sometimes you just get a lot of rain and things get wet. Just make sure if you're going to compost mortalities that you know what the regulations are for that in your state. If you're wanting to try to do this, make a business out of it, maybe you're just going to make your own compost to land apply. Maybe you're going to try to sell some product if you've got more manure than you need. That can be a great way to have some additional revenue. But again, start small. Don't jump in and try to compost all of your manure right off the bat. Do a few test windrows, get comfortable with it, figure out how to manage it before you scale it up. Use those simple monitoring tools, the sniff test, the squeeze test, and a thermometer to monitor what's going on out there. And then I talked about the emergency composting. Not a bad idea to just think about it a little bit, have a plan, think about if something did happen and you need to do that, where would you do it? And where would you get the carbon to do it? It's just having that thought through ahead of time can save a lot of panic if an event happens. So with that,
got a couple of questions here, Brian. When you started the program, you started by saying there are some reasons why you would use the anaerobic fermentation, I believe you called it.
mm-hmm.
What kind of feedstocks would you have that would require that?
It's basically the same. I mean, you're that carbon to nitrogen ratio, you're going to want to be in that same 20 to 1, 30 to 1 range, for the anaerobic method. and just get it blended. There's people are interested. I can send more information on how to go about that. The main thing is just excluding the oxygen. Other than that, the pile construction itself is basically the same. The two differences are, one, you have to cover it, and two, you have to inoculate it. So you got to think about how you're going to get that inoculant blended in. Again, it's pretty similar to making silage, and people have done it in silage bags. There's been some research in Europe, and it makes an excellent. It seems counterintuitive, because when we talk about composting, we're always saying, it has to be aerobic. Don't let it turn anaerobic. But if you do it intentionally and you inoculate it and you keep the oxygen out, it can make an excellent compost fertilizer product.
Very good. Temperature is a big thing. You've made that point several times. Tell us about the difference with weather-related temperatures.
Yeah, that can be a challenge. So for regular composting, say you're just going to do manure, even in the wintertime, you can usually hit temperature. So, those microbes will go to work. If you got enough mass in that windrow, they're relatively protected from the elements. And again, that's where, maybe you want to use a thin cover if you are trying to do this in cold weather to trap some of that heat in. That can be an advantage. But generally, there's people that compost year round. The ISU dairy, they have, of course, that's a covered facility, so that helps a little bit, but they're able to compost, pretty much year round. Mortalities is different. So I mentioned that, say it's January and it's freezing cold and you've got a mortality, it's really not going to compost until it warms up. I mean, realistically, but you build it correctly, put the mortalities in there, get them covered. It's just going to take longer. So you're not going to hit temperatures there. And honestly, for routine mortalities, you're not even probably going to bother monitoring temperature, because once it's built, you're not going to turn it anyway until that tissue breaks down. And so it's a little bit different situation there. For regular composting, you definitely need to hit temperatures, and you're going to need to actively manage it and turn it. Whereas for mortalities, you're going to have challenges in the wintertime. You still just build it like you would, and just give it some time.
When we were talking about siding a pile, that you want a solid base, cement was mentioned briefly. If this is going to be a long-term project, commercial project, is fly ash for a pack base a logical choice as opposed to something else?
That's a good question. I can't say for sure, but I don't see why that wouldn't work. I mean, that could be a good low cost option. Anything, basically anything where you're not going to be fighting the mud. So, you can do a kind of a gravel road type design, put down some 2-inch rock and cover it with screenings. That can work. Concrete can work, but it's really expensive. You could do, blacktop maybe wouldn't be as good for composting. That tends to get pretty hot, but yeah, I don't see why the fly ash option wouldn't work.
I've got one more question. You'd mentioned the 18-month rule for mortalities. Now, does that start from when the pile is built or when you declare that it's a finished product?
That's after it's finished composting, I believe, is the rule. Because it might take you, 6 to 9 months, like I said, to get it to compost. Basically, they don't want windrows or piles sitting around for years and years. Once it's done and it's finished, you've got 18 months to get it hauled out.
Very good.
This institution is an equal opportunity provider. For the full non-discrimination statement or combination inquiries, go to www.extension.iastate.edu/diversity/ext.